Good day, I'm Aljingi from Group 1. We will present EIA report for proposed solid waste thermal treatment plant in Pulau Tioman, Pahang, Darul Makmur. Below is the list of members in Group 1. The solid waste thermal treatment plant TTP construction and operation will replace the current TTP in Pulau Tioman, Pahang. The TTP will be located in about 4.5 arcs next to the present incinerator plant. The TTP located at latitude 2.827333 north and longitude 104.165222 east, approximate 0.2 km from Pantai Kampung Teke. Kementerian Perumahan dan Kerajaan Tempatan is the project proponent, and the project will be handled by the Department of National Solid Waste Management. Sumo Mutiara Sdn Bhd will undertake the construction, installation, and commissioning work of the proposed project. XCN Technology Sdn Bhd will provide technological support for the project. XCNT have responsible for incinerator construction in Pulau Langkawi and Pulau Pangkor. SMEC Malaysia Sdn Bhd will take place as project manager and engineering consultant. MSK and Associates Sdn Bhd undertake the environmental impact assessment in the project. ERA Lab will undertake the environmental monitoring, sampling, and analytical surveys for the various baseline study.
Assalamualaikum and hi everyone, I am Siti Aisyah. I will be presenting the statement of needs. Solid waste management is a concern due to its effect on public health and the environment that can contribute to health problems and poor visual to tourist places and cities. The generation of municipal solid waste is increasing every year in Peninsular Malaysia. By 2030, Malaysia might have more than 50,000 tons per day of solid waste when the country is striving to achieve the status of a developed country. The Shared Prosperity Vision 2030, National Solid Waste Management Policy 2016, 12th Malaysia Plan, Sustainable Development Agreement, Solid Waste and Public Cleansing Management Regulation 2016 is developed and applied in Malaysia to reduce solid waste generation and improve waste management. Pahang State Structure Plan 2050 is applied in Pahang State to improve the State Structure Plan 2007, which to upgrade the waste management sites with modern treatment, recycling facilities, and open dumping sites that will be replaced with sanitary landfill and incineration facilities. The location chosen is Tioman Island, which is known for fishery and tourism industry. The local population is total up to 4,000 residents, with more than half work in the fishery industry. The industry is one of the main contributors to solid waste generated on the island. Tioman Island also receives a huge amount of tourists from locals and various countries. According to Madras Daerah Rompin and Tioman Development Authority, the current average of garbage generated between 6 to 10 tons per day. During the peak tourist seasons, the solid waste generated will increase up to 14 tons per day. A high influx of tourists has contributed a huge amount of solid waste generated on the island, oceans, and beaches nearby. The newly proposed thermal treatment plant TTP is to replace existing TTP in Kampung Tekek. Existing TTP has been overloaded due to its small size with lack of maintenance and management, which has caused the TTP to break down and affect the treatment. The small size is not enough as it can only process a maximum of 6 tons, and a batch system has been used to transport waste to mainland of Mersing for processing, which may cause the pollution in the ocean. The waste in existing TTP is not segregated and ashes are dumped on nearby land, which cause bad odor is produced. The need for a solid waste thermal treatment plant is mentioned by Ministry of Urban Wellbeing, Housing and Local Government to overcome the waste management challenges. A new TTP with higher capacity, environmental friendly and latest environmental control system is the most ideal to build due to Tioman Island condition limited to expansion and minimize the impacts on the island.
Hi, I'm Fuyi. I'm going to talk about some of the parts from Session 3. The proposed TTT project uses autogeneous combustion technology which applies the double counter flow process. It includes a rotary clean system, air injection system, waste reception, waste separation facilities, KAS cooling facilities, air pollution control, and wastewater system. main process in TTP, which are solid waste receiving and handling, combustion process, flue gas treatments. After receiving the waste, it will undergo the pre-sorting and segregation to separate the recyclable materials from the waste stream. The waste will go to shredder to reduce the size. The magnetic separator separates the combustible and non-combustible waste before entering the combustion chambers. The rotary kiln has proprietary air injection system to induce combustion air in the powder flow. The waste will be reduced into ash. Secondary chamber destroy toxic chemicals. The flue gas will be subjected to cooler than to air pollution control system. It includes sirens, neutralization tower, and backhouse filter. The proposed ACT technology helps to treat solid waste with high moisture contents and lower calorific value and get rid of the issue with solid waste of high moisture content and organic matters.
I am Lam from Group 1. I am given opportunity to present project description. Solid waste can be classified into acceptable solid waste and non-acceptable solid waste. Physical characteristics of the solid waste are significant for the selection and operation of equipment, accurate analysis, and design of disposal facilities. For example, density, moisture content, size distribution of solid waste, hydraulic conductivity, and fuel capacity. The main plant process components are starting from waste reception unit. It's part of a preparatory section comprising waste of the unloading bay, waste receiving area, and feeding hopper. The waste separation facilities is used to separate the waste into two different groups, which are combustible and incombustible waste material. Sorting conveyor will be used to transfer the raw waste from the feeding hopper into trommel. Besides, trommel is defined as a rotating cylindrical perforated drums and is used to segregate the waste depending on their size and remove incombustible and recyclable materials. The waste will pass through a magnetic separator after the shredder to remove all ferrous material from the final discharge conveyor. Waste are removed within the plant by a network of interconnected conveyors using segregation and separation process. Trommel output conveyor used to transport waste coming out from the end of the trommel into shredder. Large size waste are unable to pass through the hole in the trommel. In trommel discharge conveyor, the solid waste will fall through the trommel via a tube below the trommel. The waste will segregate as it will move along the conveyor by ladder. Then, trommel output conveyor is used to transport waste coming out from the end of the trommel into shredder. The final discharge conveyor is used to transport the shared waste from the main feeding line to the ACT system. Thermal treatment facilities is the main component of TP. System will optimize combustion and minimize emission from the rotary kiln. ACT rotary kiln is a cylindrical consisting of two stationary heads which are intake and discharge heads. It's used to burn solid waste with high moisture content. The mixture of the gas generated in the rotary kiln will enter the secondary chamber at the bottom via a connecting duct. Secondary air will be introduced into the chamber to provide oxygen for the combustion. Gas cooling facilities apply to avoid segments of dust in the tube. It is used in ambient air as the cooling medium water and no wastewater will be produced. Moreover, the pollutant in the flue gas must be removed by using a series of air pollution treatment and control units such as cyclone, neutralization reactor, and backhouse filter. Pencil-type cyclone is centrifugal separator used to separate and remove centrifugal force of the particle in the flue gas. Acid gas removal by semi-dry neutralization reactor that is used to remove acid gas such as sodium dioxide and HCl in the flue gas. The chemical reaction takes place in the reactor and below. The backhouse filter is used to remove particulates with size less than 25 micron and its efficiency is up to 99.9%. An induced draft fan is used to pull the flue gas through the entire system from the combustion chamber through the air pollution control system and exits through the chimney. Dioxin control in the TTP contains any usage.
Mass and heat balance generated by the thermal treatment plant is predicted. The overall mass balance for the process runs 24 hours for the operations. The most recyclable and non-compatible waste will be removed to reduce the quantity and give more space to other waste. It is estimated 50 kg is removed. 1,383 kg per hour of waste will be treated in the rotary kilns. heat loss of latent heat and radiations are 22.4% and 5.2% of the total heat respectively. The anticipated amount of heat loss because of the removal of ash is 2,882 kilocalorie per hour. Two types of ash produced in the combustion process, which are bottom ash and fly ash. The bottom ash is discharged from the rotary kiln and is converted to an ash bagging silo located in the ash bagging room. Fly ash collected will be stored a while in suitable containers at the ash storage sheds before disposing. The enzyme will be used at the opening of the enclosed building, where this opening is used by the trucks to dump the waste in tipping bays to prevent odors. Negative pressure is created by a mechanical ventilation system to be instilled into the enclosed building to prevent odor from escaping to the outside environment. The utility consumptions include the water demand, energy requirements, and startup fuel. The water will be stored in the raw water tank with an approximated usable capacity of 17.1 cubic meter per day. The electricity demand is estimated at 320 kW per day according to the maximum workload of the TTP. The startup and the maintenance of combustion temperature in the combustion process is operated by the diesel fuel. The full operations of the TTP may require 30 qualified workers. The table shows the operating workers for TTP. Operation of TTP is fully automated. All the components will be stored automatically with one of the components breakdown. The three main process control are temperature control, basic oxygen level control, basic carbon monoxide level control. The online monitoring will look for the parameters, namely temperature set point, oxygen level, and fuel gas pollutants level.
Abnormal operation is situation where the plant fails to function as usual. It may lead to emergency shutdown to the plant. The time required for the complete shutdown is estimated not more than 1 hour. For example, failure occurs in waste preparation system, power during operation, ash handling, ID fans, primary fans and secondary fans, neutralization reactor, air pollution control system, and baghouse.
My name is Matilda and I will be discussing Section 4 on project options with my groupmate Sopo I. This chapter summarizes the project options that were considered, that are the options for waste treatment and disposal, the thermal treatment process technology options, and the options for the seating of the facility that is proposed. There are two key objectives identified for this project, which are to establish a comprehensive, integrated, cost-effective, sustainable, and socially acceptable sewage waste management (SWM), and to implement SWM based on waste management hierarchy that give priority to waste rejection through 3R intermediate treatment and final disposal. Next, I will discuss the selection criteria of a suitable solid waste treatment plant. The selection of a suitable waste treatment and disposal method has to be considered within the context of local conditions. In considering the most suitable approach to effective solid waste management, the principle of waste minimization will always be a priority. The evaluations take into consideration the geographical and climate restriction, land availability, environmental impact, financial and technical feasibility, public education and perception, type, quantity and quality of waste, product utilization, legal constraints, as well as compliance with policies, legislation, and national plans. The first treatment method discussed is landfilling, which is a method of depositing waste on land for final disposal. It is the most common and the oldest method used in most states in Malaysia. However, landfilling requires a large area for its development. In Pulau Tioman, there is a land constraint as it is an island. Besides that, the proposed location of treatment plant is near the coastal area, allowing leachate to flow into the sea and contaminating the sea with sewage. This will negatively impact the people in the area, as the sea is an important source of livelihood for them. It does not eliminate the waste issue, as it will remain there physically for a long period of time before it becomes stabilized and considered relatively safe. Composting involves the biological treatment of waste through biodegradation of the organic fraction of the waste by a aerobic process using microorganisms. In the case of Pulau Tioman, the organic content of the waste is high. Again, land is constrained in this case since it will be located on an island, as 1 square meter of land is required for each ton of compost being created. The long time taken for the composting process to be concluded may affect the running capacity of the plant, as it will not be able to accommodate the increase in waste produced due to the booming tourism activities in the island. It will likely be a more expensive alternative compared to sanitary landfill. The latest treatment is thermal treatment, or often referred to as combustion, which is a method of reducing the volume of waste to relatively inert material ash and gaseous products by application of heat. Thermal treatment of waste is an efficient method to reduce the feed volume by 85 to 90%. This treatment method is most appropriate where land is scarce and expensive and where environmental conservation of natural resources is important. It has been widely used in many countries. However, thermal treatment requires high initial capital investment and skilled staff to maintain the system, besides having a relatively high operation and maintenance cost. Thermal treatment was opted as the most stable waste management technology. There were several concerns taken into account when choosing this option, which brought along its advantages. It is discussed in the following table.
Hi, I am Po Ai, and I will talk about thermal treatment plant option. The existing thermal treatment plants operate with the traditional fuel, which is limited to the resources and might cause pollution. TTP in Pulau Tioman is a small scale, and the discussion below will present the advanced technology options employed to produce greener energy for our environments. First, gasification is one of the technology options. Gasification is a process of converting organic or fossil fuel carbonaceous materials at a high temperature. Gasification can convert the particulate to biofuels and co-produced byproducts, which is small amount intermediate products. Besides, it will produce solid residue of non-combustion materials. There are two types of bed used in gasification. Fluidized bed is a mass of particles where the coal is added to the side of reactor and cause the steam and oxygen at the bottom to have enough energy to suspend it and fluidize the reactor of bed fully. The benefit of using fluidized bed is the high conversion rate of carbon and other byproduct when a relatively high temperature is achieved. Next, fixed bed gasifier are a reactor where the feedstock in the form of large coal particles size will float at the top of a refractory line vessel. Then it sinks slowly through the bed exposed to the high oxygen level at the bottom and bed and flowing counter currently outwards in the gasifier. The advantage of fixed bed gasifier is it have orderly flow zones in processing waste. Second technology option that I'm introduced is pyrolysis. Pyrolysis is a process of chemically decomposing organic materials at a temperature above 430 degrees Celsius in the absence of oxygen. The main advantage of involving the pyrolysis process is that product can be recovery beneficial to implant energy. Heated tube is a process of pyrolysis which operates by heated externally and the temperature may reach 800 degrees Celsius. Therefore, using a heated tube can directly undertake a much bigger material without complicated primary treatment, and the municipal solid waste can pass through the tube at a set speed as the process is complete. Next, surface contact reactor is a process that tends to react in a large surface area. The benefit of a surface contact reactor is that it can maximize the rate of pyrolysis by increasing the surface area. The rotary kiln creates a swirling movement of particles to undergo pyrolysis, and it is undergoing at a temperature of 430 degrees Celsius. The main principle of the rotary kiln is heating the rotating drums inside the furnace or heat shrot. The internal environment is well controlled due to the sealed environment. Sitting options, the recommended TTP will be either rotary kiln or grade type thermal treatment due to the several factors of waste, ease of operation, and maintenance costs. For solid waste management, environment and conservation are an important aspect to evaluate the suitability of the project. A thermal treatment plant is being a solution for landfilling.
The last option proposed is the no project option, which would mean that the current method of open dumping will continue. This will cause odor to emanate in the surrounding area. The current site will be open to scavengers and pests and result in visual amenity loss, as the site is visible to travelers along the main road leading to Pulau Tioman. This is not the best option, as the area for the landfill is mostly used up or is unusable due to the constraints of terrain, resulting in new areas which need to be acquired to extend the landfill. It will likely involve acquisition of forest and swampland, which are sensitive and of high conservation value. For environmental protection and natural resources conservation are critical elements for protection of Pulau Tioman for tourism and Center for Marine Conservation.
Hi, my name is Ho Chia Yen and I'm responsible for explaining Chapter 5, Existing Environment. For the assessment of environmental impacts, the environmental feature was studied in terms of physical, biological, and socio-economic elements. Information was obtained during field survey, secondary data sources, as well as from the site visits. The terrain of the island is quite steep, rising from 75 meter to 1040 meter above mean sea level, resulting in short and steep river profiles. In the hinterlands, there are hills and mountains covered by flora of tropical forests, namely Gunung Kajang, Gunung Rombin Tioman, Gunung Sepera, and Bukit Nenek Semukut. For geographical settling, Pulau Tioman is the largest of a group of 9 islands that form the Tioman Marine Park. In addition to Pulau Tioman, the remaining 8 islands include Pulau Tulai, Pulau Labas, Pulau Sepoi, Pulau Seri Buat, Pulau Tokong Bahara, Pulau Cebe, and last but not least, Pulau Sembilang. The ecology in Pulau Tioman consists of flora and fauna such as reptilian and amphibian, mammals, birds, coral, marine organisms, and other floral species. Air quality monitoring was done at 4 locations, namely 1 at the project site and 3 at the nearest residential area. The exercise was carried out on 3rd to 6th September, first round under normal operation, and 7 to 11 October, second round under the worst condition. Monitoring for HCl was done on 14th of November. The air quality results are as follows. It can be concluded that, under the worst condition, the uncontrolled release of air pollutants within 1 hour will cause severe air pollution. Environmental noise level monitoring was conducted at 2 stations on 26 to 28 September and 7 to 9 October. 2 locations, namely N1 and N2, were chosen. The noise level results for first round and second round monitoring were tabulated in tables below. The results show that the daytime noise level at station N1 and N2 has exceeded the maximum permissible limits during the first monitoring round at daytime, except for N1 in the second monitoring round. The higher noise level is expected to be contributed by trucks travelling within the project site, transporting waste from Kampung Teke and nearby tourism area such as Marine Park Centre. The nighttime noise level for both stations exceeded the permissible level limits, except for N1 during second monitoring round. Major noise sources observed were vehicle movement, surrounding noise, and also resident activities. The population of Pulau Tioman is 3,314 in the year 208. The population of Pulau Tioman has increased steadily at an average of 4.2% per annum from 1991 to the year 2000. The population census of the year 2008, out of the 3,049 Malaysian citizens residing in Pulau Tioman, 92.1% of them are Malay, 6.8% are Chinese, followed by 0.3% of Indian out of the population, and the remaining 0.8% are other ethnicity. Based on the recent survey, most of the population have either a secondary, 34%, or primary education, 31%. However, about 24% of the population never attended school, and only 2% out of the total population further study until tertiary level. There is also a total of 4% of the population have unknown education levels. Major economic activities in Pulau Tioman is tourism. A current socio-economic survey also indicates that about 52% of the population do not have any alternative income-generating activities. The rest 48% are mainly involved in farming, tourism-related activities, and also fishing.
Hi, my name is Lo Xue. Principal project activities which are capable of inducing environmental impacts, whether adverse or beneficial. The anticipated effect of the interaction between the project activities and the environment have been described. Environmental components likely to experience potentially significant impact, such as positive or negative. The implementation and the operation of the proposed TTP are discussed in this chapter. The TTP activities and their impacts on the environment will be viewed in an integrated manner in terms of magnitude, prevalence, duration, and frequency of occurrence. The sensitive receptors identified in the project are as follows. The first one, residents of Pandai Kampung Teke, 0.2 km of the project size. The nearest houses in the settlement are about 0.2 km away from the site. The second is the residents of Kampung Mendawak, 1 to 2 km of the project site. Fugitive dust emission from the construction activities have the potential to result in localized impacts on air quality unless controlled. The example activities of fugitive dust may be generated are site clearing and earthwork when soil is exposed, wind blowing across exposed soil surface, the movement of heavy vehicles used, concrete mixing at site, and building construction activities. Fugitive dust generation due to site clearing and earthwork, wind action and transportation activities become more prominent during dry period when the soil or road surface are dry. However, the number of vehicles and equipment anticipated to be used for the project construction is minimal, and therefore the potential for excessive emission that can become potentially hazardous is not expected to be significant. The main source of air pollution will be flue gas generated by the combustion process and which will be released from the stack located south of the TDP building. Other sources of air pollution are vehicular emission and fugitive dust from operational activities. Thermal treatment of solid waste is expected to generate the following air pollutants. Water can be an important issue for waste handling and treatment development. Wastewater treatment works some industrial and rural activities. In any municipal solid waste handling facility, odor may be an issue. H2S was selected as the indicated chemical as it is easy to be detected and measured. At the current Obanam site, H2S level was found to be below the detection limit of 10. Impacts during the construction phase may be affect the water quality of the adjacent river. The turbidity of Sungai Mendawak flows along the site boundary. The main water quality impacts during the operational phase of the TTP will arise from the effluent discharge of the wastewater treatment plant. During the construction stage include site cleaning and earthwork, which result in potential soil erosion and sedimentation problems. Erosion is likely to take place when soil is left bare and exposed to rainfall and wind action. During rainy days, runoff from the site will carry sediments on the ground surface into the turbidity of Sungai Mendawak. Table below shows that the total sediment contribution from the entire project site into the river system was predicted for the 3 project phase. Impact from construction activities are temporarily in duration and can generally be controlled to within acceptable levels. The operation and movement of these machineries and vehicles will be a source of noise. Most project sites is within an area presently zoned as institution for government use, while the other surrounding areas are mainly zoned as agriculture and forests. However, a small piece of land adjacent to the proposed site is indicated as the waste disposal area.
Hi, I'm Eileen. Today I'm going to present mitigation measures. Dust emissions from soil piles of any other material during earthwork, excavations and transportation should be controlled by wetting the surface using temporary tools, windbreaks and covered truck doors. Temporary noise pollution caused by constructions should be properly controlled by maintenance of equipment and vehicles, as well as turning of engine and mufflers. A qualified engineer and supervisor should be assigned to complete the project in the shortest possible time. The construction should also be limited to daytime.
The odors emitted by TTP may be potential nuisance to the public. However, by providing negative internal pressure and installations of the biological filter, it can reduce or prevent the pestilence smell. Normal housekeeping improve operations and provide maintenance design procedure to further reduce or prevent odor emissions. When odor emissions may cause complaints, provide odor covers to the odor source should be considered, especially for the compost storage and leachate collection tanks. Proper landscaping around the facility can be used as natural windbreaker to minimize potential odor spread.
Suggested mitigation measures to minimize or eliminate the impacts on biodiversity of the proposed site, including conservation of present trees and use as windbreaks and aesthetic cover for the facility and inducing vegetation.
Proper design of operations of TP, provisions of adequate operations of waste, monitoring of compost quality based on MOE standards, and training farmers for the proper handling and use of compost at the agricultural site are the measures suggested for mitigating impacts on receiving soil.
Suggested mitigation measures for degradation of water resources include the prohibitions of uncontrolled dumping and education of workers on environmental protections.
In order to reduce potential impacts, the following strategies should be adopted. First, increase the waste collection fleet. Second, tipping floor to handle a 2-day storage capacity to prevent MSW overflow. Third, install a biofilter to ensure that the maintenance operations can be done without upsetting the whole odor control system.
To avoid the possible visual impact from the presence of TTP to the local community, especially the household near the facility, the following steps should be performed. First, maintain the cleanliness of the treatment facility. Second, by planting suitable trees such as juniper, grass, and flowers. And thirdly, fencing and screening the site with suitable trees to obstruct the plant's component from onlookers and area inhabitants. The possibility of impact on public and occupational safety may be suppressed by the following mitigation measures. First, through appropriate fences and protective measures, restrict untainted public access to TTP. Second, excavation location with appropriate safety barriers and signs around. Third, control the movement of equipment and vehicles into and out of the field, especially in construction stage. And lastly, pay attention to the safety education and training of system personnel, strengthen the compliance to safety procedures.
Hello, I'm Divya from Group 1. I'm invited as Environmental Management Framework Officer for this proposed TTP project. The management framework covers both the construction and operational phases of the project. The framework provides the basic mechanism of the organizational setup and the environmental monitoring system of the project. Organization is very important to ensure the effectiveness of the management implementation on site. In this organization, the Ministry of Housing and a local government, contractor, technology provider, and the consultant are the main parties. Move on to the reporting system, the environmental officer bring up and resolve the environmental issue that involve multiple parties in project meetings. The EMP requires environmental sampling to be carried out. The air quality will be monitored regarding on air pollutants that would be emitted during construction phase by the total suspended particles. The water quality measured at the 3 stations along Sungai Mentawang and Kampung Teka every month with parameters such as pH, BOD, COD, dissolved oxygen, and so on. Monitoring will establish on-site boundary and the noise is expected to generate from the lorries and bulldozers. The summary of 3 elements of environmental monitoring is tabulated in the report in Table 8.3 with data collected during monitoring which accredited with Scheme Akreditasi Malaysia.
As conclusion, TTP is equipped with an air pollution control system. A control emergency shutdown system also equipped to control the plant during abnormal operations. Hazard index of all toxic air pollutants are calculated. Loss during both construction and operation phase will be minimal and mitigation measures implemented as planned.